So this helps energy performance of our industry. So I will just skip this slide. So coming to petroleum refineries, I am working in BPCL as introduced by Bhavana ma'am. BPCL refinery was commissioned in the year 1955, and over a period it has increased the capacity based on the demand of petroleum products in our country, and as per the ministry directives, supply demand requirement. The current processing of crude oil in our refinery, BPCL Mumbai refinery, is 12 million metric tons per year. That is the design processing capacity. Here, various types of crude oil are received. Mainly 70 to 80% are imported, of medium to high sulfur, around 3% to 5%, and the Bombay High crude from source from ONGC, it is around 15 to 20%. Depends on the configuration and the requirement from time to time. And various products are manufactured in the refinery, including LPG, lighter product based on the boiling point, and other products like naphtha, mainly distillates, MS, petrol, diesel, kerosene, then vacuum gas oil, and residues like fuel oil and bitumen, which are heavier products. You can see the blue arrow, that is as the carbon numbers are increasing from top to bottom, the heavier crude products, they are placed in the distillation column. So the refinery operation includes physical separation as well as the conversion and treatment, that catalytic conversion and treatment processes and blending of various components to get the BS specified petroleum products. And the processes utilized for separation are distillation and atmospheric vacuum column operation. Then conversion and treatment processes, they include desulfurization to get the low sulfur diesel to meet BS6 specification as per Ministry of Petroleum and Natural Gas. Then reforming, isomerization, alkylation, these are basically various chemical processes adopted for getting the refined crude oil products. So this slide I will skip. Most important products nowadays, as far as net zero scenarios are concerned, they are like hydrogen, then LPG is important for domestic fuel at our homes. That is a clean fuel. There is no sulfur in LPG. Then petrol and diesel, they are used for transportation purpose. Diesel constitutes 50% of transportation requirement in India, and kerosene and aviation turbine fuel, these are the basic range of products for refining, obtained from refining. So coming to the benchmarking aspects in petroleum refineries in India, this study was carried out through PCRA with the help of Bureau of Energy Efficiency, Center for High Technology, over a period of years, and various results were obtained. And it was found that the specific energy consumption and energy intensity index, these are the parameters, they were compared and analyzed, and it showed various scenarios for oil refinery sectors, and it gave a direction for further improvement. So what are the specific energy consumption parameters? MBN, they are very important parameters, and energy intensity index. Its unit is MBTU per barrel per energy factor. That is the energy consumed in MBTU per barrel of crude process per energy factor. This is the simple definition. And it accounts like for simple distillation column energy factor is 1, and as complexity increases like hydrocracker and further processes are involved, isomerization, etc., the MBN, the energy factor increases. And EII is based on Solomon Study Index to measure energy efficiency, that is called energy intensity index. The energy intensity index has to be reduced over a period of time so that specific energy will be reduced and performance will be improved. What are the factors influencing energy consumption in petroleum sector? These are the major key parameters and factors identified here, but there are many more factors because oil refining is a complex process and it's very dynamic also. It depends on various feedstock of crude oil of various sulfurs, naphthenic, paraffinic or olefinic types depending upon the nature of crude oil source from either Gulf countries, Russian crude or USA or Bombay High crude, which is low sulfur crude. Then refinery configuration, they are like for latest greenfield refineries, its latest technologies are adopted, energy efficient columns and exchangers and processes are adopted where very low energy loss occurs and it works very efficiently and eco-friendly way. And old refineries, they have old units running where the aging of equipment takes place as well as efficiency also gets lowered over a period of time. So refinery configuration is important, and uh, modernization of and revamping of the old units, that is the key requirement for all refiners, for existing refiners. Then other parameters like unit capacity, then maintaining the specific parameters like vacuum, etc. If lower vacuum is there, then it is more energy efficient and optimum process for consuming less energy in manufacture of various petroleum products. Then adoption of latest process technologies having optimum catalyst and other parameters for maintaining in the controlling of the process units and reactions. So this is the basic factors which influence the significant energy consumption in refineries. The benchmarking studies, they revealed that there is potential for energy efficiency improvement in refineries where utility area that contributes 30% potential, then heaters, furnaces, they contribute, boilers also, they contribute around 20%. So 50% is thermal energy potential, saving potential is available at any point of time. Then process recoveries, 15%, it depends on the losses, etc. identified and potential opportunities available in the processes. In thermal exchangers, 15%. You will find that motors, they contribute 10% potential because normally over a period during modernization, revamping of the process units, motors are upgraded to energy efficient motors. So this is specifically unit-wise and equipment-wise contribution and energy saving potential available for gas turbines in cogeneration power plant. It is 22%, then boilers, pump motor system, etc. So this gives idea where to focus and where to optimize to get maximum benefit in the process plant. And the general recommendations which were observed in mandatory energy audit of refineries across our country, they constituted mainly heat recovery steam generator units in cogeneration power plant, that is heat recovery steam generators maximizing the waste heat, because it was observed that a lot of waste heat was getting wasted in the system. So appropriate measures need to be taken for getting the improving the efficiency. In gas turbines operation, which needs overhauling during the shutdown, etc., that helps to improve the efficiency. Then boilers, minimizing the boiler losses and utilization of energy efficient technologies for boilers like VFDs for boiler feed pump, etc. Pump motors matching with loads, steam management system, avoiding the leakages, plugging the leakages of the steam, and management of steam traps. Then lighting systems. Most of the refineries adopted LEDs for lighting purpose, and it has improved the energy efficiency in lighting system. In cooling towers, optimizing the effectiveness of the cooling towers and heat transfer optimization. So these are basically general recommendations for refining sector. So these are the best practices adopted in refining sector. As we deliberated, energy efficient designs are most important aspect at the start or at the grassroots level or start of the any refining unit. Energy efficient designs are adopted by designers. That is, earlier you can see that old refiners, they were having 3 to 5 distillation columns with 3 to 5 heaters where losses were higher side. But now energy efficient single column operation is available, and it is adopted in Indian refinery. So that has reduced a lot of energy loss and improved the energy efficiency. Energy efficient operations for boilers, heaters, furnaces are adopted. These are the best practices. Then measurement is very important, accurate measurement, and digital monitoring of critical parameters that is now available on dashboard and on mobile also, so that each and every parameter, critical parameter is monitored and appropriate action is taken if any deviation is observed in the system. So this avoids the losses and trips and shutdown of the units. Fuel consumption is monitored and optimized based on the conditions and the cost analysis and economic analysis of fuels. Minimization of losses in hydrocarbon industry is most priority job, because if higher the losses, higher is the revenue loss and hydrocarbon loss. So every action is taken whenever the losses are found or analyzed, and they are minimized. So action plan is made and losses are controlled. So to just give you a brief about the case study measures taken at BPCL refinery, Mahul, Mumbai, some of the process related measures, they include heat integration and energy efficient state of art latest crude distillation unit number 4, which was commissioned in the year 2015, and that has improved a lot energy efficiency, and a lot of revenue has been earned through that. That has replaced old CDU4 unit which was commissioned in the year 1955. So that has been replaced by state of art unit. This is the heart of the distillation unit in refinery. Then hydrogen management processes that must be optimized, and specific actions are taken in unit and hydrogen unit for recovery of hydrogen, which was earlier going in off gases, and the revenue was getting lost. So this measure has been adopted, and hydrogen saving has been carried out. As far as process plant goes, the ISO unit was having the distillation column, which was single wall column, but then R&D efforts were made, and with the help of manufacturer and supplier, the design changed to double wall column for ISO unit. That has also reduced significant energy consumption. In the area of thermal and electrical energy, it was found during energy audits that some of the insulation lagging for steam lines were damaged, and superior insulation was adopted for these steam lines and steam headers, so that heat loss could be reduced. So separate insulation surveys are carried out. So these are the ideas adopted in refinery to improve the insulation performance. Flare gas is one area where during the petroleum refinery, it's a dynamic system, and if any changes in process parameter like pressure or temperature occurs, and if any emergency like power failure, or if any unknown emergency occurs, which is not which is detected. So that time you will find that lot of flare gas is sent to flare stack, and you will find that black smoke will be coming out through the flare system. But now, with the help of flare gas recovery equipment, this flare quantity of flare hydrocarbons, they are recovered, and they are strictly monitored through the control system, and minimum flare is maintained. This has contributed to a lot of revenue savings. Another measure adopted in refinery is online chemical cleaning for furnace and heater tubes, which help to remove the fouling and deposits on the radiation tubes, which led to the better heat absorption in radiation section and heat recovery. So that has reduced the fuel consumption and improved the furnace efficiency. Condensate recovery in process plant is also another area where it is found that a lot of condensate recovery potential is there, and most of the condensate, more than 60% condensate, is recovered, and it is sent back to boiler system for making the steam. In the area of digital and online monitoring systems for energy management, BPCL Refinery has energy portal for online monitoring of various process parameters that help to optimize the energy consumption. Critical parameters are monitored continuously, and deviations, if found, they are marked, and action is taken to remove the deviations. So this help in improving the performance of energy efficiency. So coming to specific energy conservation measures, I will just share some of the specific equipment related how energy has been saved in our refinery, and most of the these ideas, they are shared at appropriate platforms with other refineries, and they also take ideas, and we also share, we also get ideas from other refineries to implement. This is one of the energy conservation idea which came through the energy auditing through PCRA, that is polymer chemical coating for cooling water pump internals. So as per the supplier, the guarantee was given to improve the performance of the pump efficiency by 3%, but in the field it is found that it is more than 3% and it runs around more than 5 to 7% also. So this is the case study for a 24-inch split casing pump, and you can see the uh, coating has saved 66.6 kilowatt. So coming to another case study area, that is energy efficient turbo air blower, that is permanent magnet DC power air blower has been implemented in ETP air requirement, and it has replaced the twin lobe compressor. So as mentioned, permanent magnet motor that requires power to rotate the stator, and it is very highly efficient in operation. There is no gearbox. It is having variable speed drive, no lubrication because it works on airfoil bearing. So there is no oil lubrication consumption. And these blowers, turbo blowers, they are low noise blowers, and it's air cooled. So this is the frame internal showing how the twin turbo blowers they operate. So if we compare the old system, twin lobe system, and the new turbo blower, the efficiency increased by more than 15%. Here you can see the benefits accrued, and it runs in lakhs and lakhs rupees saving. So another case study example I would like to share is the provision of installation of electrical heat tracing system in place of steam heating for heavier oil, fuel oil, and bitumen product rundown lines. So it has helped to reduce the surface heat loss, and it was found very useful and energy efficient system. This is a picture which is showing how steam insulation was provided for heavy oil, and now the EST has been provided. It's very less, it requires less maintenance, work efficiently. That has given the energy savings around 5.3 crores per annum, and payback period is hardly 2.1 years. There are many energy conservation measures adopted for other equipments like compressors, air leaks, then pumps and high efficient motors, then VF provision of VFDs, etc. For water pumping also, variable speed drives adopted, VFDs are adopted in refinery. The monitoring of pumps and steam traps are done through digitally smart meters that has helped to identify the critical aspects of the pumps. And we found that the digital monitoring of steam traps, which is located in the field, that has helped to identify the deviated operation of the traps, like blow through or plugged or flooded status, so that timely action is taken by maintenance team and loss of steam is avoided. This is another good example to share with you all is that in our cross country Mumbai Manmad Bijwasan pipeline, which is 24-inch pipeline and more than 1500 kilometers running from Mumbai refinery to Bijwasan, Delhi. There, the specific chemical drag reducing agent chemical introduced in the hydrocarbon inside the pipeline, and that it found that it has helped to increase the flow, and a lot of energy saving occurred, and it has bypassed one of the intermediate pump station near Vashala, near Nashik, and uh, it has saved a lot of actually this energy saving occurred after the Manmad location, not Vashala, after the Manmad location, but one intermediate pump station has been stopped and it has saved a lot of power. Then solar and other renewables are adopted at refinery. So some of the PCRA tips I will just share. I will share the PPT also with you all, and I will just briefly tell you. The tips are very uniform and applicable to all industries. They are very general, but it is proven from time to time that they are very useful. And if we adopt one or two tips in our operation and work area, that will help you to save the energy. Because these tips have been generated over a period after a lot of study in industry across country, and they are all proven. So they are related to heaters, furnaces, boilers, avoiding the leakages and improving the performance. So by overhauling of air preheaters, by changing the old burners by two new energy efficient burners, the efficiency is improved. Steam trap management is adopted across refineries in India through the trap suppliers, and it is found that it is very useful and it saves a lot of revenue also, and a lot of steam is saved. Because you will find that in complex refinery processes there are thousand and thousand traps are adopted, and there are different types: float traps, thermodynamic traps, bucket traps, etc. So it's very sensitive area, and you will find some of the locations, some traps will be not behaving properly, or there are leakages, or there are certain uh, uh, deviations occurring, temperature, pressure. So it needs a lot of periodic monitoring. But the steam trap management systems, they yield a lot of revenues. Then various measures are adopted for electrical motors. These are all general nature based on the energy audit, mandatory energy audit carried out in refineries. Over a period of last few years, the metric ton of oil equivalent MTOE savings that is given here and you will find that the savings have been increased due to adoption of various energy conservation measures implemented over a period. And because of these mandatory energy audits through Bureau of Energy Efficiency, it has really helped to identify and implement the ECM in refineries. So this is the list of ENCON schemes implemented in Mumbai refinery. 41 schemes were implemented, and benefits numbers, they are dynamic numbers. 124 crores were accrued with energy efficiency, energy intensity index reduced by 4.28. And the list of ECM adopted last year, these are some equipment specific as well as some are related to the steam traps, and some are related to process, that is preheat exchanger cleaning, etc. So if you will find that during the start of the distillation unit, after the shutdown and maintenance overhauling is done, the preheat etc. are improved. But over a period, you can say end of the run of the equipment, say after 2 years, 3 years operation, continuous operation, the preheat exchangers, they don't yield the proper heat transfer, and you will find loss of energy in that case. So specific cleaning adopted for each preheat exchanger, and that preheat is improved upon, which led to fuel saving in various numbers. So what are the challenges? There are many challenges. Each and every refinery as well as industry, they face a lot of challenges in energy performance improvement areas. So I have jotted down few challenges like the time available and support and focus required from management. Sometimes that is not uh, appropriate because it is not production line. So every industry face similar challenges. Then there are many hurdles we find in making the energy reduction plan. Then lack of focused approach and work for implementation of ECMs. These are general challenges everybody face, like metering systems failure or insufficient, cost of the metering system, then these approvals are required, etc. So what is the way ahead? We have to adopt a few areas like optimum requirement for operation, but at the same time improve the energy performance by having better energy efficiency. For the energy efficiency improvement, we need competent people. This is very important aspect, because if we have very good machine, but if person is not knowledgeable, then machine may fail and it cannot be giving the efficient operation. So we have to adopt the energy culture, people culture, create awareness so that performance is maintained. So this is the summary sheet for all energy efficiency management and energy conservation in industry. How to use the more efficiently the processes to reduce the emissions, produce energy cheaper, and use the green energy. So what we need to improve is to improve the monitoring and operations by controlling the online processes and optimizing the processes. Heat integration is required Even cooling integration is also required, because cooling loss is also very important as well as heat loss. So you have to balance both. You have to identify the waste generation and reduce the waste, and stop the leaks. Leaks in terms of water leaks, steam leaks, instrument air leak, or compressed air leaks. So whatever leaks are stopped, you will show the money indirectly. Refining sector catalyst plays a key role in manufacturing various petroleum products. So adoption of latest catalyst developed by the suppliers for optimizing the process is key for improved performance. Net zero perspectives, as government directives are clear and mandated about the net zero actions. So companies and refineries and oil and gas sector is also getting ready for net zero future by adopting energy efficient measures and energy conservation and reducing the energy intensity. But it requires a lot of finances, then technical capabilities, technologies, and developing our own resources. The technologies like carbon capture, they are future technologies and it will come up in future. So this is all from my side. So I will just share with you the Mahatma Gandhi's quote, "Be the change you wish to see in the world." Thank you.
Yeah. That was great sharing, Mr. Atul, and your experience speaks a lot. I mean, the way things have been implemented. I mean, that can really be seen, whether it was a PCRA or and then using those learnings of PCRA actually into BPCL can be seen from your presentation. And we hope that all the industries have people like who are actually passionate about energy efficiency and sustainability, so that each and every industry becomes net zero, and our goal for net zero is achieved faster. And now we have questions. So yeah. So the first question actually Anish has lot many questions. I will read one by one and then you can answer that. Yeah. So hi sir, it's nice to learn from the presentation. Is steam tracing or electrical tracing which has low energy cost? In case we recover heat from flash steam or condensate line for the same purpose, what is your take on that?
I can share my experience in our process unit, like bitumen blowing unit. The rundown lines were requiring a lot of steam, and we found that the maintenance of the steam lines, insulation, then steam trap management, that was having its own cost, and electrical heat tracing has removed all those costs. So I prefer electrical tracing because it is a clean operation, and it doesn't require steam maintenance, etc., management of traps. So it's better. It's good. You are suggesting that flash steam, etc., is recovered. So you have to see the feasibility of and cost economics for both cost of electrical heat tracing and the management of steam through the recovery of steam. So, but I prefer electrical heat tracing is much more beneficial as compared to steam tracing. Thank you.
Yeah. His next question is, can you, Anish, the vendor details, you can directly connect with, we will be sharing his contact details and you can take it from him. He needs a vendor who provided split casing pump for polymer coating. So that can be directly shared by him. I'll be giving his email address here and you can take it from him. Now, another question is, can we use acoustic imaging technology to identify faulty steam traps? Or else, what all instruments is required to carry out the same?
Yeah, it's a good question. We utilize three measures or methods for identifying the steam trap malfunction. That one is visually seeing the steam leaks. There is formula given by Center for High Technology based on the length of the steam uh, coming through the steam trap, that is leakage steam trap, I mean, or say flange leak or any other leakages from the steam trap manifold. So it gives overall or general idea how much quantity of the steam is leaking. Based on that, the action is taken. If it is very small leak, then uh, various methods are there to reduce the steam leaks. And maintenance of steam trap is also another aspect. Another method is utilization of steam trap instrument. It is having probe, and if you uh, touch the surface of the tip of the this probe at the trap, it gives the temperature measurement, and it gives the quantification also how much steam loss is occurring. So that is very useful instrument, and each leaky steam trap, uh, how much steam loss is occurring, you will find it out, and based on that you will have your own steam trap management action plan. So these are the methods, but I don't know about what you are suggesting, the caustic application for steam trap leak identification. I'm not aware about that.
Okay. Now, his another question is, what is EII reduction? Can you elaborate the factor a little bit?
EII is energy intensity. Basically, it is energy intensity index, and it is generally found that how much specific energy is consumed in the unit. That is calculated through the specific formula. Okay, and based on the Solomon Associates International Benchmarking Agency, they have compared the energy intensity index EII for all refiners world over, and that is a very good indication comparing with latest refineries as well as old refineries, and how to improve the performance. If energy intensity index is low, then that means you are having less energy required for the production of petroleum products, and you are working efficiently. So our approach is always to minimize the energy intensity index number. Earlier it used to be 87, now it has came down. And how it is reduced? By adopting energy efficient measures, by replacing the less energy efficient motors or equipment, then improving the energy efficiency in boilers, furnaces. Then I have given one or two examples, like improving the preheat exchangers performance, so that you can have more heat transfer. So like that, measures are taken, and the energy intensity is reduced. So it is nothing but, just to understand, it is a specific energy consumption indicator. So if you have less energy per ton of product, then you can get the factor energy intensity index. So for specific refinery units, each unit is having its own energy intensity index for each refinery. So I have one slide explaining the energy intensity index in detail. Is it okay or shall I further deliberate?
Yes, it's okay. And like if he has more doubts about it, he will get in touch with you.
Okay.
Yeah. And because we have many questions over here. So Anish, your all other questions we will be, you can contact him personally. Now we have next question from Mr. Thomas George. He says, excellent station. Thanks a lot. Covered almost all aspects of energy efficiency in petroleum refinery. However, no mention found on criticality of selection and use of right instrumentation. Could you please give some examples where the right instrumentation helped in energy savings in refinery and petrochemicals?
Okay, as time is limited, so I could deliberate on various aspects. Your specific question is on instrumentation. In the process, various instrumentation is utilized, like pressure monitoring, then temperature monitoring, then differential pressure across the reactor, for exchanger also, distillation column also, level indication. So this IS application for instrument monitoring and control that is adopted in refinery and in control room. You can, if you see the operation of distillation column or reactor profile, etc., or exchanger profile, this that is continuously monitored. And if any change occurs, like because of some pressure change or temperature change, or maybe depending upon the quality of crude oil process in the process unit, the action is taken based on the process control measure or methodology adopted. There are automatic controls, cascade control, and the settings are given. And there is alarm system as well as interlock system. So the instrumentation interlocks, they are very sensitive and critically monitored. And in normal running operation, people are not authorized to change the settings or to bypass the critical instrumentation systems, like furnace trip settings or fuel gas trips or level settings for reactors and for distillation columns. If one need to, because of malfunction, need to bypass the critical instrumentation, then there is a protocol and system adopted in refinery, and it must be authorized from the highest authority, head of the department, so that everybody will be aware about the bypassing of the system, because then risk in running operation increases, and you have to attend the problem immediately and set the critical instrumentation in line or in the system. So it's very important aspect, and it is monitored continuously and with very high sensitivity.
Okay, great. So that was a very detailed answer. I hope it satisfies you. Yeah. Another question is from Mr. Padu Padmanabhan. His question is, to what extent are the refinery energy efficiency measures based on sophisticated design tools like pinch point analysis, etc., to optimize heat transfer, power heat optimization, and cooling? Also, whom does the refinery energy manager report to? And is the energy efficiency work done in-house or is it outsourced?
It's a good question.
Yeah.
And in our power plant and in our process unit, pinch analysis adopted, and with the help of, normally our consultant is in PSU refineries in India, consultant is Engineers India Limited, and through them many technical expertise is harnessed and utilized, as well as refineries, they share these technical aspects with other refineries through Center for High Technology platform and through meetings. pinch analysis is very well done over a period or every 3 years or 4 years, and the approach is taken so that optimum process is running or GT operation as well as distillation column, and minimum gap will be there so that loss will be minimized and you will get higher efficiency. So it's very useful tool for optimizing the process. And at the same time, the supplier and manufacturer, they have their expertise, and they also monitor critical parameters for like catalyst operation and other reactor performance. So they also guide from time to time. So your second question is to whom the energy manager reports and how the measures are adopted. The energy manager reports to the technical services cell, to the head of the department of technical technology in refineries, and the ECM, etc. They are studied and implemented through the technical department with the help of other departments like mechanical maintenance and operations, and then they are reported through appropriate channel to the government agencies like Bureau of Energy Efficiency through the MEA reporting or MEA protocol.
Yeah. Yes, I hope Mr. Padu that satisfies your question. And yeah, so now the question there are no more questions, I suppose. And thank you, Mr. Atul Vyawahare, for this detailed presentation and giving an insight of how in-house team can bring out this energy, implement energy conservation measures and lead the company to net zero. So that was very clear from this presentation. And before we log out, let me remind you that all the recordings of this our sessions are uploaded on our LinkedIn web page of the chapter, and also now they will be available on our YouTube channel. So you will be getting this information again through our social channels, and also through emails. In the next emails that follows, all the information will be there regarding our YouTube channel also. So stay tuned with us, and let us know what more topics can we include. And like if you are willing to present your case studies or any particular new technologies, you're always welcome to share your views with us.
Thank you.
Thank you so much. Thanks all for attending this session. And thank you, Mr. Vyawahare, once again.
Thank you.